There are a lot of numbers out there. In fact, there are an infinite number of numbers out there, though some more than others. Sure, you have your 1s and 5s and 11s, and you can't forget your 23s and 106s, and who could possibly miss the proud million? And there are fractions and decimals and irrational numbers and real numbers and prime numbers. To put it simply, numbers are freaking cool. There are so many ways to work with them and to have them do what you want, but there are some numbers we don't use very often. These are the shadowy guys hanging out deep into the right side of the number line. Today, we're going to gaze into the twilight zone of the math world and look at some really big numbers. This is List. Number 6. Avogadro's number. In 1811, Lorenzo Romano Amadeo Carlo Avogadro de Quaregna e di Cerreto, or just Avogadro for short, made possible the key factor in understanding just how small atoms really are in their relationship with the larger world that we occupy. He proposed that the volume of a substance, in this case a gas, was proportional to the number of atoms that it makes up. This number was 6.022 times 10 to the 23rd power. While it was initially meant to define the number of atoms in a gas, it is now officially defined as the number of atoms in 12 grams of carbon-12, otherwise known as a mole. After being stretched out from scientific notation, Avogadro's number is written out as 602 sextillion 200 quintillion. Number 5. The 48th Mersenne prime. Prime numbers have intrigued people for centuries. Ever since we realized numbers that were only divisible by 1 in themselves were special, we've been looking all across the numeroverse to find bigger and bigger prime numbers. For a while, there weren't a lot. Up to until about the 1800s, the largest prime number we knew about was only somewhere in the hundreds. However, everything changed when a French monk by the name of Mersenne came along and developed an equation to figure out incredibly large prime numbers. This equation, 2 to the power of n minus 1, paved the way to finding some of those massive primes. For a time, until 1952, the reigning champion was 2 to the power of 127 minus 1, which is a number 39 digits long. Then, when computers came about, the way to find Mersenne primes became easier, and the numbers increased exponentially. Finally, on January 28, 2013, Dr. Curtis Cooper of the University of Central Missouri discovered the 48th known Mersenne prime. That number is this porker, 2 to the power of 57,885,161 minus 1. The size of this number is incredible too. It has almost 17.5 million digits. Number 4. Brain capacity. Let's say you wanted to figure out the highest meaningful number, but you wanted that number to be things you can count. There are a lot of things out there. For example, when you play a game of chess, there are 5.2 times 10 to the 49 possible ways the board could look with pieces on it. When you shuffle a deck of cards and then flip them all over, the number of outcomes are 8.065 times 10 to the 49. Getting bigger still, when looking into the observable universe, we can estimate there are about 10 to the 80 atoms that make up the universe. Okay, that is pretty big, but how about Planck volumes? A Planck volume is the smallest possible space something can take up and still make physical sense. So if you plug that number into the size of the universe, which is 92 billion light years in diameter, making its volume 3.8 times 10 to the 50 cubic centimeters, provided the universe is spherical, that number comes out to be 2.38 times 10 to the 83rd power. But we can't stop there. How many things are there that you can imagine? Well, since you can't visualize everything in the universe, but you can visualize things that don't exist, a purple parrot, for example, the number of objects, concepts, and abstract ideas your brain can conceive is somewhere around 10 to the 10 to the 16 things. Number 3. GOOGOLPLEX. Created by Edward Kastner and named by his nephew Milton, the number Google is famously one of the biggest numbers in public knowledge. A 1 followed by 100 zeros, it is a number higher than the amount of atoms and Planck volumes in the universe combined. However, Kastner didn't stop there. Initially, a GOOGOLPLEX was meant to be a 1 followed by zeros until you got tired, but eventually was changed to a 1 followed by a Google zeros. To understand the smallest inkling of how large that really is, to even write such a number would take more paper than there is space in the universe, provided it's finite, even if you wrote in 1-point font. Still, if you wanted to actually find out how many zeros a Google actually is, this website has actually done it. Check it out if you feel like scrolling down forever and ever. Number 2. The longest time. If GOOGOLPLEX wasn't big enough for you, here's this massive number. 10 to the 10 to the 10 to the 10 to the 1.1 is massive because you have to start calculating the number by multiplying 10 by itself 10 times, then multiplying that number by itself 10 times. Then repeat that process 2 more times. And then you still have to add in the 1.1 bit. But what does this number mean exactly? The answer is complicated, but it has to do with a Poincare recurrence time, which is the time it takes for something to revert back to its original state from a state of chaos. For example, if you took a bunch of marbles, put them in the corner of a box, and shook the box evenly, how long would it take until the marbles naturally came back to that same corner? The answer is a long time, but that's just for a small thing like a box. If you wanted to use the universe as an example, you'd have to consider that the universe has a lot of space. In order for the universe to naturally coalesce into a single point, it would take this many years total. Number 1. Graham's number. But now comprehension of even numbers like GOOGOLPLEX won't save you. Graham's number is, quite frankly, stupidly big. To even understand what it's for is difficult, but to be very general, imagine various groups of people, each with a color either red or blue. What Ronald Graham, the creator of this massive number, wanted to know was what the minimum number of people you would need to meet certain conditions of red and blue connections. Now, the number begins with a mess of threes. First, you take 3 to the power of itself 4 times, which means you take 3 times 3 3 times, which is 27. Then you multiply 27 by itself 3 times, and then do this over and over again until you've reached the last iteration, which, by the way, is a number bigger than just about any calculator can figure out. But anyway, now you have a number that is redonkulously big, but we're not done yet. This number is just G1. To get to the next part, G2, you would need to put the number we just got and raise 3 to that many powers of itself. So G2 is already too big to even start to comprehend. Now to get to Graham's number, you'll need to repeat the process we just used to get from G1 to G2 62 more times. What you are left with is a number so unbelievably vast it's almost too big to do anything with, but it does have a use. That number we were trying to figure out with the groups of people, the exact number we're looking for is somewhere between 11 and Graham's number. Thanks for watching this episode of List. If you have any other topics you want me to count down, leave it in the comments or email me at stuffyou'veprobably.wondered@gmail.com. Also in the comments, tell me, is there a number you like the best? What's the highest you've ever counted in one shot? Either way, I'll see you next time on List.